Hey everyone, and welcome to a deep dive into something truly game-changing for developers, the power of adaptive AI. If you've spent any time working with large language models, or LLMs, for code generation, debugging, or even just brainstorming, you know the frustration. You're often stuck in a cycle of static prompts, right? You ask a question, you get an answer. Then you need to re-explain the entire context, or refine your query repeatedly, because the AI seems to forget what you just told it. It's like using a debugger that can only follow a predefined script, unable to truly understand the runtime behavior or evolve its analysis as the code state changes. It can feel incredibly inefficient. This isn't just a developer concern, by the way. That constant back and forth impacts everyone, from PMs seeing project timelines stretch due to repetitive dev tasks, to security teams needing more nuanced threat analysis that static prompts simply can't provide. Now imagine an AI that actually thinks with you, one that learns, adapts, and maintains context throughout your entire interaction, anticipating your next move rather than waiting for rigid instructions. This is the promise of adaptive AI, and specifically, what Claude Opus 4.6 Developer Edition is bringing to the table. Picture a moment where your AI assistant isn't just spitting out code snippets, but truly understanding your codebase's evolving state, suggesting refactors based on observed runtime patterns, or even helping you architect complex systems by dynamically adjusting its recommendations as new constraints emerge. This shift, from static prompts to adaptive intelligence, opens up possibilities that go far beyond simple code generation. It's less about asking the right question every single time, and more about engaging in a true, intelligent collaboration. But how does it actually work? And what does adaptive thinking even mean for an AI? Let's break it down. Before we dive deep into Claude Opus 4.6, let's really nail down what adaptive thinking actually means in AI. It's easy to confuse it with just being smart, but there's a crucial distinction. Think about traditional prompt engineering. You craft a perfect prompt, the AI gives an answer, and then maybe you refine that prompt for another go. It's often a series of independent interactions, or at best, a conversation where the AI's internal state doesn't fundamentally shift beyond its immediate context window. Adaptive thinking, however, is fundamentally different. Imagine an AI that doesn't just process your input, but actively adjusts its internal understanding and behavior based on new information, ongoing interactions, and even subtle shifts in context. It's not just following a predefined script, it's evolving its own script in real time. This is like our central analogy, a dynamic debugger that intelligently adjusts its analysis based on the code's runtime behavior and evolving states, rather than just following a predefined script, revealing deeper insights. It's about continuous feedback loops, where the AI's internal state is constantly being updated. So what's the mental model behind this? At its core, adaptive AI operates on a recursive cycle of perception, reasoning, and action. It perceives new data or user input, reasons about its implications in the context of all previous interactions, and then acts or responds accordingly. This loop isn't fixed, it's incredibly fluid. You might be thinking, isn't that just a really long context window? Not quite. In real systems, this shows up when an AI assistant doesn't just answer your question, but follows up with a clarifying query, or adjusts its tone based on your previous responses, almost anticipating your next move. This isn't just a developer concern. It fundamentally changes how product managers design user flows, requiring them to think about dynamic, evolving user journeys, rather than static conversational paths. The power here comes from the AI's ability to truly learn and evolve throughout an interaction, rather than restarting its thought process with each new prompt. It can handle ambiguity better, maintain coherence over longer, more complex dialogues, and even infer user intent that isn't explicitly stated, because it's building a dynamic model of your goals. This lays the groundwork for truly intelligent agents, moving beyond sophisticated chatbots to genuine digital collaborators. Now that we've defined what adaptive thinking is, let's pull back the curtain and see how Claude Opus 4.6 actually achieves this under the hood. So, how exactly does Claude Opus 4.6 pull off this adaptive thinking magic? At a high level, it operates through a continuous, dynamic cycle, an adaptive loop that constantly refines its understanding and responses, much like how we learn and adjust in real-time conversations. It's not just following a script, it's building and evolving one. First up is contextual perceptions. Opus 4.6 excels at taking in vast amounts of information. Not just the immediate prompt, but also the entire conversation, history, user preferences, and even external data you might feed it. Think of it as having incredibly sharp senses, constantly scanning the environment to build a rich, nuanced understanding of what's happening. Next comes the reasoning engine. This is where the core computation happens. Opus 4.6 analyzes the perceived context, identifies patterns, and forms hypotheses about the most appropriate next step or response. This is where our central analogy truly shines. It's like a dynamic debugger that intelligently adjusts its analysis based on the code's runtime behavior and evolving states, rather than just following a predefined script, revealing deeper insights. This ability to dynamically analyze complex scenarios isn't just a developer boon. It's also critical for security teams detecting evolving threats, or product managers understanding user journey shifts. Then, iterative refinement kicks in. The model doesn't just make a single decision. It often simulates multiple potential paths, evaluates their outcomes, and refines its internal state based on what it learns. This continuous internal feedback loop makes its responses incredibly robust. I've seen teams leverage this for complex code refactoring, where Opus 4.6 suggests several approaches and helps evaluate the pros and cons, leading to far more stable solutions. Following this, we have action generation. Based on its refined understanding, Opus 4.6 generates a coherent, contextually relevant output. This could be anything from writing complex code, summarizing technical documentation, to crafting an entire strategic plan. It's about generating the right action at the right time. And it doesn't stop there. Self-correction mechanisms are built in. If its initial action leads to an unexpected result, or if it receives explicit feedback, Opus 4.6 adjusts its internal models. It learns from its mistakes, enhancing its performance for future interactions. This is crucial for developing reliable, trustworthy AI applications. Underpinning all this is a sophisticated, modular architecture. Essentially, a highly advanced transformer network combined with specialized modules for different adaptive functions, allowing it to scale and specialize its intelligence. But the key takeaway for developers isn't the theoretical complexity. It's understanding how these intertwined mechanisms give us an AI that truly thinks with us. So how do we actually interface with this advanced intelligence? Alright, we've peeked under the hood at how Claude Opus 4.6 thinks. Now, let's get practical. How do we, as developers, actually talk to it? At its core, interacting with Claude Opus 4.6 is all about API calls. Think of it less like a simple chat window, and more like opening up a new, highly advanced debugger session. You're sending specific inputs, asking for analysis, and receiving dynamic insights back. Getting comfortable with these endpoints is your first step to unlocking its power. And this initial setup isn't just for developers. How these APIs are configured directly impacts data privacy policies and compliance standards for the entire organization. Now you might be thinking, isn't this just like any other API call? Send a string, get a string back? And yes, the basic send message or create completion functions will feel familiar. But the content you send, your prompts, becomes crucial. It's not just about a single question. It's about providing enough context, enough state, for the adaptive AI to understand the ongoing conversation. This is where you start shaping its adaptive behavior. This is where the analogy of our dynamic debugger truly clicks. Imagine you're debugging a complex system. You don't just run one test. You step through, inspect variables, and adjust your focus based on the runtime behavior. Claude Opus 4.6's API works similarly. You're feeding it code snippets, documentation, even mock conversations, and it adjusts its internal analysis to provide richer, more relevant outputs based on the evolving state. I've seen teams leverage this for things like simulating dynamic interviewer interactions, where the AI's feedback adapts based on the candidate's previous answers, providing far more meaningful prep than static practice questions. So what are some beginner-friendly use cases? We're talking about automating repetitive coding tasks, like generating boilerplate functions, writing unit test stubs, or helping refactor small sections of code. For content generation, Think beyond marketing copy. Use it to draft comprehensive internal documentation based on code comments, or create dynamic onboarding guides for new engineers. Even complex tasks like summarizing lengthy error logs or translating legacy code snippets into modern syntax become surprisingly accessible. The benefit here extends beyond just engineering. Product managers can leverage its summarization capabilities to quickly digest user feedback or generate initial feature requirement drafts. Getting started means understanding basic authentication, structuring your API requests, and managing conversation history to maintain context. Tools like Python's requests, library, or curl are your friends here. Your first adaptive AI project might just be a simple script that helps you explain complex code to a junior developer, or generates descriptive comments for a new class. But this is just the beginning. In our next scene, we'll dive deeper into how these initial integrations lead to early wins and pave the way for even smarter, more robust development capabilities. So you've seen how to get started with Claude Opus 4.6's API. Now let's talk about the immediate wins you can expect and where this journey is truly headed for developers. First up, adaptive AI dramatically boosts your productivity. Imagine a coding partner that truly understands your intent and adapts as you code, going beyond mere autocomplete. It's about intelligent suggestions, proactive bug detection, and refactoring assistance that anticipates issues. It's like having a dynamic debugger built right into your workflow, intelligently adjusting its analysis based on runtime behavior and evolving states, revealing deeper insights and cutting down debugging time significantly. Beyond just speed, adaptive AI enables us to build far more robust and resilient applications. Think about systems that can self-heal or adapt their behavior in real time based on fluctuating user demand or unexpected external events. We're moving away from rigid, rule-based systems to applications that truly learn, evolve, and handle ambiguity with grace. This means less brittle code, fewer edge case crashes, and ultimately, a more stable product. For development leads, this translates directly to reduced operational overhead and improved system reliability. You might be thinking, how does this actually look in a deployed product? In real systems, this shows up when an application dynamically adjusts its UI or workflow based on individual user behavior and preferences over time. Picture a moment where your customer support bot doesn't just answer questions, but learns your customers' frustration points, proactively offers solutions, and even escalates complex issues with full context, creating a much more satisfying experience. This isn't just a developer concern. It fundamentally reshapes user experience design and provides crucial data points for product managers to iterate on features, and even informs marketing strategies by highlighting true user engagement patterns. And this is just the beginning. The future development possibilities with adaptive AI are immense. We're looking at personalized learning platforms that adapt lesson plans to each student's progress in real time, or highly sophisticated fraud detection systems that dynamically learn new attack vectors as they emerge. Developers will be building intelligent agents that can orchestrate complex workflows across multiple systems, automating tasks that once required extensive manual scripting and human oversight. It's about building truly intelligent systems that anticipate, learn, and act autonomously. Of course, these powerful capabilities also bring new challenges. We need to be thoughtful about managing complexity, ensuring ethical AI use, and understanding how to effectively debug systems that learn and adapt. The skills we develop today, like effective prompt engineering and understanding AI's mental models, will be crucial. But the early wins in productivity and robustness are clear, and the path to truly intelligent applications is open. You're probably eager to jump in and experiment with these powerful tools yourself. And in our next scene, we'll equip you with a comprehensive developer's toolkit to help you start your journey with Claude Opus 4.6. Alright, you've seen the potential, you understand how adaptive AI, like Claude Opus 4.6, can act as that dynamic debugger, intelligently adjusting its analysis rather than just following a rigid script, revealing deeper insights into complex problems. Now, the big question is, how do you get your hands dirty and start building? We're going to outline your essential developer's toolkit for diving into adaptive AI. First up, the absolute fundamentals. Go straight to the source. Anthropic's official documentation is your Bible. It's where you'll find the core API references, SDK guides for Python, and crucial quick start examples. Understanding these foundational elements early not only helps you get code running faster, but also provides clearer visibility for product managers to estimate development timelines and plan feature roadmaps, ensuring everyone's aligned from the start. Next, let's talk libraries. While you can certainly interact with the API directly, Python developers will find the official Anthropic Python SDK indispensable for streamlining calls and managing responses. But don't stop there. Libraries like LangChain or Llama Index provide powerful abstractions and integrations, helping you build more sophisticated adaptive workflows, manage memory, and orchestrate complex chains of thought. These tools handle a lot of the boilerplate, letting you focus on the adaptive logic. Now for experimentation, you might be thinking, where's the sandbox? The Claude console offers an interactive playground where you can test prompts, observe adaptive behavior, and iterate quickly without full code deployment. Think of it like a live debugger for your AI, letting you step through and tweak its delicious thought process. In real systems, this shows up when a dev team uses the console to rapidly prototype different chain-of-thought strategies, observing how Claude Opus 4.6 dynamically adjusts its reasoning paths for troubleshooting or complex data analysis before committing to full code. Beyond direct coding, remember the power of community. Explore developer forums, Discord channels, and open-source projects centered around Claude and adaptive AI. Sites like Hugging Face often host fine-tuned models or example implementations that can jumpstart your own projects. Learning from others' successes and challenges can save you countless hours and expose you to patterns you might not discover on your own. Finally, your first adaptive AI project. Start small. Pick a well-defined, contained problem where adaptation truly adds value. Don't try to build the next world-changing AGI on day one. Focus on one adaptive element. Maybe a tool use scenario where the model needs to intelligently decide which tool to use, or a dynamic summarization task that adjusts its output based on user context. Iterate, learn, and be prepared to refine your approach. But what happens when things don't go as planned? What are the common pitfalls and challenges developers face when working with adaptive AI? That's what we'll dive into next. So you're excited to build with adaptive AI, which is fantastic. But like any powerful tool, working with something like Claude Opus 4.6 comes with its own set of unique challenges that developers often hit. It's not always straightforward, especially when the AI isn't just following a predefined script, but actively adjusting its analysis based on evolving states, much like our dynamic debugger analogy. One of the first hurdles is prompt engineering. You might be thinking, I know how to write good prompts, but with adaptive AI, it's less about a perfect initial prompt and more about dynamic guidance. You're not just issuing a command, you're setting the parameters for an intelligent process that will change over time. It requires a mindset shift from static instructions to providing adaptive cues and feedback, allowing the model to truly learn and pivot. Your goal is to shape its evolving understanding, not just dictate a single output. Then there's the critical issue of context management and drift. In real systems, this shows up when you have an AI assistant that starts off incredibly helpful, but over a long conversation or a series of complex tasks, it seems to forget earlier details or loses its initial focus. This context drift can make adaptive AI seem less reliable. The solution often involves implementing sophisticated memory strategies, whether it's summarizing past interactions, using vector databases for relevant retrieval, or explicit state management within your application code. This isn't just a developer concern. It fundamentally impacts the user experience that product managers are striving for, and ensuring coherence over time is key to broader adoption. Finally, debugging unpredictable behavior can feel like trying to debug a mind, not code. Since adaptive AI, by its nature, doesn't always follow a fixed path, its outputs can be harder to trace back to specific inputs. It's less about step-by-step execution and more about understanding why its analysis adjusted a certain way. The best practice here is robust observability, logging not just inputs and outputs, but also key internal states or reasoning steps the AI provides. Iterative testing, where you tweak prompts and observe how the model adapts over multiple turns, is essential. Think of it as developing intuition for its adaptive logic. Mastering these challenges transforms you from a user of AI into a true architect of intelligent systems. Next, we'll explore something equally vital: how to develop these powerful adaptive AIs responsibly and ethically. As developers, the power of adaptive AI, like Claude Opus 4.6, comes with significant responsibility. We're not just writing code. we're shaping systems that learn, evolve, and profoundly impact users. This final, critical step in our journey together is about understanding the ethical considerations that must guide every adaptive AI project. First, let's talk about fairness and bias. You might be thinking, my data is clean, so my AI is fair, right? Not always. Bias can creep in from historical data, underrepresented groups, or even how the model is evaluated. As a developer, actively auditing your datasets and ensuring diverse representation is paramount. This isn't just a technical fix. It's a critical component for product managers defining user stories and even legal teams assessing regulatory compliance, ensuring the AI serves everyone equitably. Next, we need to tackle transparency and explainability. Adaptive AI models can feel like black boxes. They make decisions, but it's hard to see why. But for trust, especially in critical applications, we need to understand the logic. Just like a dynamic debugger helps us understand complex, evolving code states, we need ethical frameworks that allow us to inspect and understand the adaptive AI's changing decision-making process, even as it learns. This means building in mechanisms to trace decisions, not just predict outcomes. Then there's safety and robustness. Adaptive AI's ability to continuously learn means it can sometimes evolve in unexpected, even undesirable ways. We need robust testing frameworks to identify edge cases and prevent unintended harm. In real systems, this shows up when an adaptive AI designed to optimize a supply chain unexpectedly prioritizes cost-cutting so aggressively that it compromises safety standards or employee well-being due to a subtle shift in its learned parameters. Developers must consider failure modes far beyond typical static software. Data privacy and security become even more complex with adaptive models. As these systems continually ingest and process new data, safeguarding sensitive information is a moving target. We need strong encryption, access controls, and strict adherence to privacy by design principles, not just once, but continuously as the model evolves. This brings us to responsible deployment and governance. Ethical AI isn't a pre-launch checklist, it's an ongoing commitment. Implementing continuous monitoring, human-in-the-loop interventions, and clear update policies are crucial. This demands close collaboration with operations teams for deployment oversight and with business stakeholders to define acceptable risk tolerances. Ultimately, building responsible adaptive AI is a core part of the developer's craft. It means asking tough questions, advocating for ethical design, and constantly learning. Thank you for joining me on this deep dive into adaptive AI. If this video helped you understand the challenges and potential of Claude Opus 4.6, please hit the like button. What's your biggest takeaway or ethical challenge when building with AI? Let me know in the comments below. Don't forget to subscribe and hit the bell for more insights, and you can grab the full playbook and all resources mentioned today via the link in the description. Keep building and build responsibly.